Hello students, myself Pallavi Jaiswal. Here in this video, we will discuss the topic numerical question based on time invariant and time variant system. Before moving on to the question, first of all, we can understand what is time invariant and what is time variant system. Time invariant system is that system which does not vary with respect to the time, and time variant system, from the name itself it can explain, it does vary with respect to the time. Time invariant system does not vary with respect to the time. Time variant system vary with respect to the time. Now with the help of example we can understand this more deeply. Here we have the question: check whether the following system are time invariant or time variant. Here we have three questions. First question, yt equals to sine of xt. Second question, y of n is equals to n of x of n. Third question, yt equals to xt cos 200 pi t. First and third question is continuous time system function, and the second is discrete time system. As you know, if the notation is like this, y of t, that means this particular system shows the continuous time system. If it is written like y of n, then you can understand the given system is discrete time system. Now one by one we can solve each of the question. First, yt equals to sine of xt. Before solving this question, one thing I must explain here. As you know, in any system we require some input, and depending upon this input our system provides some output. So as you can see, yt, that is output, is nothing but a function of xt, because our system depend upon input and our output is produced with the help of input. Hence yt is must be a function of xt, then only our system provide output. Hence you can see yt is nothing but a function of xt. We can write like this: yt is a function of xt because our system depend upon input and our output is produced with the help of input. Hence yt is nothing but a function of xt. So now we can solve this question. Yt equals to sine of xt, that means yt is equals to function of xt, that means yt is equals to sine of xt. Sine of xt. Now we have few steps to be followed. First, so we have to determine our output expression of the system for delayed input. That means we have to delay our input by the value t1. Here we have input xt. Now what we have to do in first case, we have to delay our input by t1. So by delaying our input by t1, we have the expression like x of t minus t1. So by delaying our input by the value t1, we have the expression x of t minus t1, and in this case we have output like this, t comma t1. This particular expression express that the output due to delayed input. We in the first case we only delayed our input, not the output. We only delayed our input. In this case we have the expression for output like this. As you can see here, y t comma t1 shows our output due to the delayed input, and function of x of t minus t1 shows that we have to delay our input by t1, and in our input is sine of xt, so we can delay like this, x of t minus t1. We have the expression like this. Now what we have to do, we have to delay our output expression, which is output yt by t1. Now in second case what we have to do, we have to delay our output by t1. So in this case we have to write y of t comma t minus t1, because here in second case what we have to do, we have to delay our output by t1. In this case whatever be the t content, present in the expression, we have to shift that t by t minus t1. We simply replace our t by t minus t1 in case when output is delayed by t1. So, as you can see, we have the expression like this. As you can see, what we have to do here in second case, we have to delay our output by t1, and hence we have this expression which is y of t minus t1, and we have sin of xt. So we can replace every t. So here we have t in x of t, so we have to replace x of t minus t1. So we have two expressions, which is first this and second one is this. So on comparing these two equations, we get sin of xt minus t1, and here also sin of xt minus t1. Both the expressions are equal, hence y of t comma t1 is equals to y of t minus t1. Both the expressions are equal. When both the responses are equal, in order to determine this, whether the given system is time variant and time invariant, if both the responses are equal, in this case the system is time invariant. If this expression is not equal, then we can say the given system is time variant. If it is equal, that means the system is time invariant. It does not vary if it is equal. Okay. Now we can understood with the help of second question. Moving on to the second question, we have second question. Y of n equals to n of x of n. This is discrete time system expression. We can solve similar way a continuous time system as well as discrete time system, but here there is a difference in the notation only. So first what we have to do, we have to delay our input in first case. So we simply delayed our input. Here in earlier question there is t, so we can delay it by t1, but here in discrete time system we have n, so we can delay it by n1. What we have to do, we simply delayed our input. Here we have input n, we delayed our input here we delayed our input by n1. So we have the expression like this, x of n when delayed by n1, we have the expression like that, n minus n1. In this case we have the output like n comma n1. We have the output expression like this, we have the input expression like this. So we have the expression y of n comma n1 shows our output expression when input is delayed by n1, and as you can already know this, y of n is a function of x of n. So we can write here like this, function of x of n minus 1, because we have to delay our input by n1. So in this we have to apply this in our given function. So y of n comma n1 is equals to n of x of n minus. We only delayed our input. So here we have x of n as an input. So we can write x of n minus n1. Now what we have to do? Now in second case we delayed our output expression by n1. So y of n is delayed by n1. So we can write y of n comma n1, and we have to replace every n by n minus n1. In second case, what we have to do, we have to delay our output by n1. So we can write like this, y of n minus n1, and we can replace n by n minus n1 in whole expression. So as you can see, what we have to do, we have to, in given function, what we have to do, we have to simply delete our output. So y of n minus n1, and replace every n by n minus n1. So here we have n, so n minus n1, and here we have x of n, so we have x of n minus n1. We have this expression after delayed our output by n1. On comparing these two equations, as you can see, here we have x of n minus n1, but here we have n minus n1 x of n minus n1. So here there is a difference between this two expression, here we have simple n, here we have n minus n1. Hence, this two expression is not equal. Y of n minus n comma n1 is not equals to y of n minus n1. Hence, the given system is time variant. It does vary with respect to the time. Because if the expression is equal, then we can say that the given system is time invariant, but the given system is not equal, hence the given system is time variant. Now, last question. Here we have yt equals to xt cos 200 pi t. So, as you can see, first earlier two questions. First, what we have to do? We have to delete our input only. So, by delaying our input, we get this expression yt comma t1 is equals to x of t minus t1 cos 200 pi t. Because why this expression comes? Because we have to delete our input only in this case. Now, in second case, what we have to do? We have to delete our output by t1. So, in that case, we have to replace every t. We have to replace every t by t1. So, we have this expression like this: y of t minus t1 is equals to x t minus t1 cos 200 pi t minus t1. We get this expression on comparing these two equations. First expression here, x of t minus t1 cos 200 pi t, and in second expression x of t minus t1 cos 200 pi t minus t1. On comparing these two equations, we conclude that both expressions are not equal, because in earlier expression we have cos term which is only t, and in second expression we have cos term which is t minus t1. So both the expressions are not equal, hence the given system are time variant. Thank you so much.